In this video, we will go through chapter 10, section 10.4, which is motion in two dimensions. Okay, motion in two dimensions. Okay. In previous video, we used the Newton's second law, okay, F equals to ma, where F is forces, m is mass, and a is acceleration. So we know that F and A both has got direction and magnitude. So therefore we can apply the vector for forces and accelerations. Okay, so let's go through the example 8 from the textbook. Example 8. Okay. Here is the example 8. It says, in this question, I represent the unit vector Q east and J represent the unit vector Q north. A resultant force of 3I plus 8J Newton acts upon a particle of mass of 0.5 kg. A. Find the acceleration of the particle in the form of Pi plus Qj meter per second squared. Okay. A resultant force of 3I plus 8J. So F equal to 3I plus 8J Newton. Acts upon a particle of mass of m is 0.5. Okay, so for part A, we want to work out the acceleration. Okay, so we want to work out A. We know that F is equals to mass times my acceleration. F is equal to 3I plus 8J equals to 0.5 times by A. Therefore, A is equals to 3I plus 8J divided by 0.5. So we divide 3 and 8 both by 0.5. A is equals to 3 divided by 0.5 is 6. I plus 16J meter per second squared. Part 2. Find the magnitude and bearing of the acceleration of the particle. So find magnitude and the bearing. Okay. Magnitude and bearing. Magnitude means the length of the force or size of the force, or in this case, acceleration. Okay, so we know that the acceleration in vector form is 6I plus 16J. Therefore, the magnitude of A using the Pythagoras, it would be square root of 6 squared plus 16 squared, which is 2 root 73 newtons or 17 point not newton, meter per second squared, which is 17.1 meter per second squared. Okay, so to find the direction, all we need to do, just to make it easier, let's sketch the diagram. Okay, let's say This is A. Okay, because it says 3i plus 8j. Okay, 16j. It will be in first quartile. Both 6 and 16 are positive, obviously. So this one is, let's say here is 6 and 6i. I is on x-axis and j is on y-axis. 16j. So let's work out this angle theta. Let's call this angle theta. So tan theta is equal to opposite over adjacent. Okay, 16 over 6. So theta is equal to 69.4 degrees. Okay, so the bearing is always from north. Since the bearing is from north, in fact we want to work out, if this is toward north, we want to work out this angle. Okay, the bearing would be, obviously all of this is 90 minus, and theta is 69.4. 69.4 degrees, which is equals to 0, 20.6 degrees. Okay, 0, 20. Okay, end of the example 8. Okay, let's move on to the next example, which is example 9. Okay. Example 9. It says forces F1 equals to 2i plus 4j, F2 equals to minus 5i add 4j Newton, and F3 is equal to 6i minus 5j Newton. Act on a particle of mass of 3 kg. M is equal to 3 kg. Okay, find the acceleration of the particle. So we want to work out the acceleration. Okay. We know that acceleration is F is equals to mass times acceleration. Okay, so we're gonna to use this formula. So F represents the resultant forces. Okay, to find the resultant forces, since there are 3 forces acting on particle, all we need to do, just add the I components and J components separately and write it down as a resultant force. F is equals to F1 plus F2 plus F3. However, you can write down 2i plus 4j in as a column vector as well. 2, 4. Add. Minus 5, 4. Add 6 minus 5, which is 2 add minus 5 is minus 3. Minus 3 add 6 is just 3. 4 add 4 is 8. Minus 5 is 3. Therefore, 3i plus 3j newtons is the resultant forces. Okay, so F equals to ma, therefore 3i plus 3j is equal to 3 times by acceleration. A is equal to 3i plus 3j divided by 3, which is I plus j meter per second squared. Okay. So here is the end of the example 9. Let's move on to the last example, which is example 10. Okay. A boat is modeled as a particle of mass of 60 kg. Example 10. A boat is modeled as a particle of mass of 60 kg, being acted on by three forces of F1. All are given as a column vector, AT and ATI plus 50 J Newton. F2, 10P, 20 Q Newtons. And F3 is minus 75 and 100 Newtons. Given that the boat is accelerating at a rate of, given that A is equal to 0.8 and minus 1.5 meter per second squared. Find the value of P and Q. Okay. To find the value of P and Q, we can apply the Newton's second law of the motion, which is F equals to ma. So F represents some of the forces, the resultant forces. M is mass and A is acceleration. So let's find some of the forces first. F equals to 80, 50 add 10p, 20p add minus 75, 100, which is equals to 80 minus 75, which is 5, 5 plus 10p. 50 add 100, 150 add 20p is 150 add 20 q, I mean it's not p, 20 q. Okay, so we've got resultant forces. Now let's apply the formula. F equals to ma, so 5 plus 10p 150 plus 20q is equal to mass times my acceleration. Okay, the mass is 60 kg, acceleration is 0.8 minus 1.5. Okay, for these two to be equal, the I and j components must be equal. So let's rewrite it. 5 plus 10p and 150 plus 20q must be equal to 60 times 8, which is 0.8, which is 48, and 60 times negative 1.5, which is negative 90. Therefore, 5 plus 10p is equals to 48. 10p equals to 43, and therefore p equals to 4.3. Okay, similarly 150 plus 20q must be equals to minus 90. 20q is equals to minus 240, therefore q is equals to minus 12. Okay. After watching this video, you should be able to do exercise 10D, which is page 167, 68, and 69. Okay, so exercise 10D. Page 167, 8, and